Hello everyone. So today we're going to find the domain of a function, and then we're also going to figure out what does the domain of a function have to do with calculus. Well, there is a connection between the domain of a function and continuity, and so we're going to talk about that in this video. But first, let's just discuss how do we find the domain of a function. Alright, and when I'm talking about this, I'm talking about it specifically algebraically. So first, let's just discuss some math laws that cannot be broken, and therefore determine which numbers are included or excluded in the domain of a function. Alright, so first we have that we cannot divide a number by 0. Okay, so in other words, 2 divided by 0, for example, is undefined. However, I just want to note to you guys that 0 divided by a number equals 0. Okay, so 0 in, i.e., 0 in the numerator is okay. Okay, so there's no problems when I have 0 in the numerator. However, if I have 0 in the denominator, in other words, I'm dividing by 0 there, there's a problem, okay? Because when we do that, when we divide by 0, you see in the calculator that you get an error message. Alright, the second thing is we cannot apply a logarithm to a number that's less than or equal to 0. Okay, so in other words, log of 0 is undefined, and so is log of -1, log of -2, so on and so forth. And this works for all logarithms with any base. Alright, so it could be log base 10, it could be the natural log with base e, it could be log base 2, it could be anything. Alright, so anything that's a logarithm. Okay, and the last one here is we cannot take the even root of a negative number. Okay, so you guys remember that we can't take the square root of a negative number, but more abstractly I'm saying we can't take the even root of a negative number. So for example, here, in other words, the fourth root of -1 is undefined in the real numbers. Okay, and that's because our root number right here is even. Okay, and so why did I bring up these math laws? Basically, it will help you hopefully remember these bullet points here that I have for finding the domain of the function. Because here I'm going to list out some common functions that you've seen before, and so you'll see why I'm saying these functions in particular, the domain is all real numbers, and for these other functions I need to do some work to figure out what the domain is. Okay, so for polynomials, exponential functions, cosine, sine, and odd root functions, the domain is all real numbers. This is because, right, for all of those types of functions, I'm not breaking any of those math laws that we had up here, right? So I'm not dividing by 0, I'm not trying to take the log of a negative number, I'm not trying to take the even root of a negative number. Okay, so there's no issues with those functions, and so that's why the domain there is all real numbers. Whatever I plug into those functions, I will get out a number. Alright, what about the rational functions though, right? For rational functions, so functions that look like fractions, right? We want to set the denominator equal to 0 and solve for x to find the x values not included in the domain. Okay, so set the denominator equal to 0 and solve for x to find x values not included in the domain. Okay, so that's the key part there. Because whatever x values I find when I set up that equation, basically I'm saying that when I plug in x back into the function, you're going to get something divided by 0, and so that's a big issue there. Okay, so that's why I'm saying whatever those, when you set up that equation and you find those x values, those are the x values not included in the domain. And then otherwise, the function is defined everywhere else except for those excluded values. Okay, and then we also have that for even root functions. What I'm going to do is set the expression under the even root greater than or equal to 0 and solve the inequality. Okay, so the reason why I'm just focusing on what's under the root, okay, is because whatever I plug into the root, it needs to be a number that's greater than or equal to 0, right, for it to be defined. And so if I have some expression that when I plug in and I get a negative number, I can't plug in a negative number into an even root. And so to find said values where there's an issue, I need to, again, like I said, set the expression under the even root greater than or equal to 0 and solve the inequality. And then lastly, I was telling you that the inequality will give you the domain. Okay, what am I going to do for logarithms? So for logs, I'm going to set the expression inside the log greater than 0 and solve the inequality. All right, and then the inequality will give you the domain. So similar idea like for even roots, except you want to specifically set it greater than 0, so not greater than or equal to 0, because remember, we can't take the log of 0. All right, if you put log of 0 in your calculator, you'll get an error message. And last but not least, we didn't talk too much about the tangent function, all right, because above you saw that for sine and cosine, the domain was all real numbers. But for tangent, the domain is all real numbers excluding these values, pi over 2 plus k pi, where k is an integer. Okay, and so here I'm kind of trying to show you why that's the case. So recall that tangent of x is defined as sine over cosine. Okay, and also that cosine of pi over 2 equals 0. So what I'm saying is that if we did tangent of pi over 2, that's equal to sine of pi over 2 over cosine of pi over 2. And what happens here is I get 1 over 0, which is undefined. Okay, so that's why I'm saying that pi over 2 is definitely not in the domain of our tangent function, but in fact it's not just pi over 2, but it's multiples. It's pi over 2 plus multiples of pi. Okay, so in other words, 3 pi over 2, for example, wouldn't work. 5 pi over 2, for example, also wouldn't work. So all of those values would be excluded from the domain of tangent. Okay, so yeah, basically a lot of this, was me talking, but just so you have all of those bullet points, you want to make sure that you understand why we're doing what we're doing to find the domain for rational functions, even roots, and logs. And again, it's connected to those math laws that we just cannot break that I first talked about in the beginning.